we looked at odd powers of the cosine, odd power of the sine. What happens if we have neither? If both cosine and sine have even power. So that will be the next case. So we look at even power of both. In this case, we need to do some double angle activity. So we use the double angle identity. The double angle of the cosine, we have three possible. We have three options. So if we're looking at cosine of 2 theta, if you remember your trigonometry, one identity will be cosine squared minus sine squared. Cosine squared plus sine squared equal 1, but cosine of 2 theta is cosine squared minus sine squared. Now, what you can do next, if you substitute cosine squared with 1 minus sine squared, then you have 1 minus 2 sine squared. Okay? And if you substitute the sine squared with 1 minus cosine squared, so you have cosine squared minus 1 plus cosine squared, or you end up having 2 cosine squared minus 1. Okay? Now, what if we need to solve for the sine squared or the cosine squared? Because remember, we have even power of both. So we need to find a replacement or substitution to either the sine squared or the cosine squared. Okay? So let's look at if we solve for the cosine squared. Well, you have 2 cosine squared equal cosine 2 theta plus 1, right? Or 1 plus cosine 2 theta. And then you divide by 2, so you have 1/2 actually, let's write it here. Cosine squared equals 1/2 1 plus cosine of 2 theta. So this will be our replacement for the cosine squared. Okay. And if we are solving for the sine squared, you can look at it, come with it on your own. So let's see, we are here, so 2 sine squared equal 1 minus cosine 2 theta, and sine squared by itself will be 1/2 times 1 minus cosine 2 theta. So no matter what we choose to replace, the sine squared, excuse me, or the cosine squared, you end up having cosine 2 theta. What does it tell you? It tells you that you need to work with the differential sine theta d theta, because you're going to solve for the cosine. Let's see if I have a very quick example. I do. So we'll finish with the next example. I think it's example 3. Let's evaluate we'll go 0 to pi. This time we'll go to a definite integral. 0 to pi sine squared theta d theta. And this indeed will be a quick one because we're going to solve for sine squared. So immediately we're going to say this is the integral I. 0 to pi, instead of sine squared, we're going to pick up the last substitution. We write it as one half times 1 minus cosine of 2 theta d theta. Break it down into 2 halves, so we have the integral. 1 half is a common factor, so we have the integral from 0 to pi d theta minus the integral 0 to pi of cosine 2 theta d theta. The result? The integral of d theta is theta. The integral of cosine 2 theta will be minus 1 half, because we need to compensate for the 2 theta, 1 half sine 2 theta. And we evaluate it from 0 to pi. Okay? What I did is the antiderivative of cosine 2 theta is 1 half sine 2 theta. If you take the derivative, you get 1 half times 2 cosine 2 theta. And of course, sine of 2 pi and sine of 0 is 0, so this term is 0, and we end up having 1 half times pi, or pi over 2. I think time for me to stop. So I'll stop, and I'll see you at 3:30 for the test review. And the test review will take place right here.